Hey guys, so in this video I'm just going to show you how to do some partial fractions. So the point of partial fractions is if you have a fraction of polynomials like this, where the top degree is smaller than the bottom degree, and the bottom is factorized like that, then we can sort of split this into a sum of two fractions, where the bottoms are the factors, okay? And we want to keep the top degrees smaller than the bottom ones. So in this case, because the bottoms are just linear terms, we only admit constants on top there, okay? So the point is to find these two values of a and b that make it equal, that make these two forms the same thing. Okay, we'll see in integration that there's a few advantages to writing the top complicated fraction as the sum of the two simpler ones, but we want to find those values of a and b that make them equal to each other. So what we do is we pretend we just add those fractions. So we do that by using common denominators and things like that, and we see that for the fractions to be the same, those top bits, those numerators have got to be the same. So we try and compare those ones. Okay, so for now we just ignore the bottoms and we say these two things have to be identical. And our goal, remember, is to try and find those values of a and b. So how we do that is we're allowed to substitute any value of x we like into there. Okay, so we can try and eliminate the b by substituting x equals 1. That would take away, zero out that whole b term there. So if x equals 1, on the left we have 2 times 1 plus 10. On the right we have a times 4. So it'll be 12 equals 4a, so a must equal 3. Notice that the whole b term was zeroed out. Okay. And in a similar way, we can calculate b by zeroing out the a term. Okay, and how we do that is we put x equals negative 3. Okay, and so on the left we have negative 6 plus 10, and on the right we have b times negative 4. And again, the a term this time has been zeroed out. So we get what? 4 equals negative 4b, so b must be negative 1. Okay, and those are our two values of a and b then. So return now to what we had before. We wanted to have that top fraction as a sum of those simpler bottom ones, but now we've just worked out that a must be 3, b must be negative 1, and so that tells you that that this is the partial fraction decomposition. Okay, and so the whole point was that these two things are the same, and the bottom one is called the partial fraction decomposition. Okay, you can check real quick that if you do that fraction subtraction on the bottom, you can check that it actually does give you the top fraction. Okay, and so that's the whole point of this. We want to split that top one into those two. Give you one more example. Okay, so this time the difference is we have a quadratic term down the bottom, and I guess the only difference that makes is that because it's quadratic, it admits a linear numerator. Okay, so you see for the x minus 2, the top still has to be a constant because the degree's got to be 0, it's got to be less than 1. But on the right, because it's a quadratic there, okay, the degree can be anything less than 2, and so we allow it to be linear as well, so bx plus c. So we do the same thing, we just add those two fractions, leaving the a's and b's and c's there, and we get this mess. And then we compare the numerators again. Okay, and so I'll skip ahead to this bit, okay, where we compare those numerators. And again, our aim is to work out what's a, what's b, what's c. So again, this time we can zero out the entire right-hand term. If I put in, I think, this one, I can put in x equals 2. So on the left, we'll have 2 times 2 plus 4, which is 8. And on the right, we have 8a as well. 2 squared plus 4 is 8. So we get 8 equals 8a, and a equals 1. Okay, and so that means that we can replace the a now with a 1. Now we want to work out b and c. Okay, now zeroing out the b is quite easy. I just put in x equals 0. Okay, so if I want to get rid of that b term, I just put in x equals 0. I sub that in. On the left, I have 2 zeros are 0, plus 4 is 4. And on the right, if x equals 0, I just get 4 minus 2c. And because 4 equals 4 minus 2c, I get c equals 0. Okay, I'm skipping over the algebra part quite quickly for this example, because I hope you've seen it already, you sort of see how this works. Alright, so c equals 0. And so that means I can just take out that c there. So all that's left is the b. a few things you can do from here. You can just sub in anything you like now. You can sub in, say, x equals 1 or something if you want to find that out. But one sort of quick way to do it, and just to show you this other way of dealing with these coefficients, is we can equate the powers of x. So I'm going to equate the powers of x squared. Right, and on the left, of course, we have no x squares, and so it'll be 0. But on the right, we have the 1x squared from the left term and a bx squared from the right term. Okay, so that tells you that 0 from the left side must equal 1 plus b, and so b must be negative 1. So that way we have it then, a is 1, b is negative 1, c is 0. So we return now to the fact that the original fraction must equal the sum of the two split ones, and so we just put in a is 1, b is negative 1, c is 0, and we get this. And that's the partial fraction decomposition for that fraction on the left. There is one more special case where the denominator has a perfect square or some power of linear power of x or something, but I think I'll do that with you guys when I come back. So this should be enough for you to work through 4.5. So yeah, hope you can get that done, and if you need to rewatch anything, feel free to do so, but I'll see you guys next time.